Hello and welcome to part 2 of my video. In this video I will be talking about the player and all of the different components that go into it. What you can see here is the player class, the player header file. It is a child of the GameObject class, and it takes in the documentation, this is what would be considered the blaster. I erroneously named it the player when I first created it. Let's step into the creation. So at the beginning, it creates 3 instances of the player strategy. This will obviously be going over our strategy pattern. I will go into that in a little more detail in a little bit. First, I will run through all of the components of the player itself. So it has a speed that is set by a general header that includes many different settings for the players, or for different movement, or different components that need to be referenced frequently. I made a separate header file that contains all of that, and many different places get from there. Let's see. Down here you have the set control, which is where it will establish that the game will start off in AI mode by utilizing the AI strategy pattern, or the AI strategy, instantiating the all instantiation. Next to the set controls, so this is where the player is allowed to switch between AI and first player mode. When you hit it, it will swap out the strategy for the appropriate one. It will swap the sound controller, waves, and the score, so that it is being placed in the correct location. On the update, it will call the play mode's movement. So each of these movements are different, and I will be demonstrating that in a moment. Also, it will determine whether or not it is firing, and then it has these two buttons to check whether or not it is about to be swapped, whether or not you want to swap first player or last player. These are basic clamps to keep it within the player bounds. Down here, this is where I reset the player if the player should die. So as you can see, it will subtract lives from it, and if it runs out of lives, then it will reset the controls to the computer. And this will continue for the computer as well. If the computer continues to die, then it will reset itself. Get score simply returns the current score. Let's see. Fire calls the bullet factory to create a new bullet. I did not use the single bullet design decision. I went with a factory, so I'll be able to demonstrate the factory as well. Destruction simply deregisters the player and is called at the end of the game when the game is ending. That is to say, you're closing out the window. These are the collisions with the player, which will call the sound manager and tell the player that, and it will activate the reset player status. Alright, now on to the strategy pattern. I'll move to the generic strategy, which consists of 3 different functions: a constructor, a movement function, and a deflect function. Parented, this is the virtual function, so it contains nothing in it. over here in player AI, in the AI strategy pattern, I define that, first let's look at the header. So this one has movement controls and containing information so that it knows how it should be moving and where it should be moving to. AI is now back into the actual proper thing. These things are declared up here so that they aren't redeclared every time it's created. That is to avoid unnecessary redeclarations. Here you can see a very, very basic initializer where it's simply setting the movement. Swap movement is a simple switch statement which, when called, will determine its previous move and will set it to the appropriate correct next move. This is also the same strategy that I used in the centipede head for determining where it should be moving. Up here is the movement thing, which will be called every single which is called an update, so that means that it is called every single frame. Fire is always set to true for the blaster because the blaster is simply just always firing. And it will move itself along the current move along the current movement path that has been set for it in the form of the previously declared arrays. So that's the AI strategy. Very, very simple. Onto the player strategy, similar, but with few key differences. It's simply, in the initialization, it's simply registering input, and it is tracking for these inputs specifically, which will move it, and then also be able to set the fire to firing or not firing, and also its deflection is based off of removing it from a previous position, from the position it is attempting to move towards, that is. All right. Now onto the bullet. Bullet is very simple, moves forward, created at a specific location, specifically the player. It is created at the player, and it will move upward on the screen until it encounters anything or it reaches the edge of the screen. So here you can see it's instantiated, and then here is its instantiation post for recycling. Add to scene. This was before I started using the generic term instantiate for all of my adding it to the scene. Yes, so the player keeps track of the bullet and whether or not the bullet is around. And as you can see here, and that will determine whether or not it can fire. So there can only ever be one bullet on screen at a time. There can be 0 bullets on screen at a time, but never more than 1. And that keeps track of, and the player keeps track of that. The blaster keeps track of that. For the collision of the bullet, it will simply remove itself from the scene. It will call remove from scene, where it will clear the player's bullet and mark itself for destruction. This is also an example of the listener pattern, where the player, so the entire player bullet interaction is a listener pattern, where the player is listening to the bullet, and when the bullet dies, it will inform the player that it is dead and that it can free up it can free itself up to fire another bullet. Next, let's look at the first of our many factories, the bullet factory. This bullet factory is a singleton. It will create one instance of itself and then reuse that instance for everything. It contains a stack of bullet pointers, although the stack will never reach above 1. So technically I could have gotten away with simply having a single bullet pointer. as you can see, it will call functions hidden behind the privacy wall to ensure that it is using just our instance. And it will call the private creation and recycling. So let's take a look over in that. So for the creation, it will create a bullet pointer and then check the bin. If the bin is empty, it will create itself a new bullet and instantiate that bullet and then add it to the scene. If not, it will, if the bin is not empty, then it will remove from that bin that bullet, and it will register that bullet to the scene, and then use the bullet's own add to scene or instantiate to start the bullet off. When the bullet is destroyed, as you can see with the set external management, it will call this the private recycle, where instead of simply getting rid of the memory, it will keep track of the memory. It will push the bullet onto the stack that was previously created. And then there's the destructor, where when the bullet factory is being destroyed, it will check with the bullet bin, and while the bullet bin is not empty, it will delete the bullets inside. It'll delete the bullets that are inside it to make sure that all the memory is gotten rid of in a reasonable fashion. All right, that is all for the player. Thank you, and I will see you in part 3, where I will be discussing the mushroom field and the centipede, and also the other critters. Thank you, and see you in part 3.